So in this class, it is important that you understand your whole numbers. This is part of your syllabus as you are working with this term. In this term, actually, you need to understand the basics of your whole numbers. So in this case, we've got a summary that is elaborating the number system that we have. So before that, I just need you to understand the few basics that we are actually going to talk about. Actually, going to talk about this summary later on. But the major part that I need you to go through is to understand the rational numbers. This is the most important part. What is it that we are actually talking about here when referring to the rational numbers? Remember, guys, we've got different numbers that can be presented. We have got different numbers that can be presented when we are referring to this part here, which is referred to as the real numbers, which are represented by the letter R. So the letter R represents the real numbers. There we are referring to any number on the number line. Meaning to say, as long a number can be on a number line, that is, we are referring all rational and irrational numbers put together. So for us to understand this, we need to understand the rational numbers and the irrational. What are these numbers? Because at the end, they are going to help us to define the real numbers, because it consists of those rational and the irrational numbers. So that is why I'm saying it is the most important part for you to understand before we move into the other types of numbers. So when you are referring to the rational numbers, as we had this from our previous grades, we had that it is any number that we can be able to write in the form of A over B as a fraction like this. As long you can write your number in the form of A over B like this, but on a condition now that the A and the B that you are referring to, the A and B, that is the most important part there. They are supposed to be integers. So A and B, they are supposed to be integers. So we can just write it this way to represent the integers. So we are going also to go through the letters to represent the Z. When you see this, it is for the integers. So integers, we are talking of what? The positive or negative whole numbers. Positive or negative whole numbers. Also, B is supposed to be part of those integers, but B is not supposed to be equal to 0. So this is the most important part. Yes, B is an integer, but B is not supposed to be equal to 0. This one. Remember, when you had this from your grade 8 mathematics, we were saying we cannot write a number like 1 over 0 like this, 2 over 0, 3. This does not exist. Mathematically, we cannot have our denominator like this with a 0, because that fraction does not exist. You cannot simplify that. All right, let's bring our calculator. This is an introduction. We need to understand where it is going to and where it is coming from. So this is 3 over 0 like this. Let's just have this one and see on your calculator. That's math error to show this cannot be simplified. You cannot simplify this type of a fraction. Take any number that you want, 100 over a 0 like this, okay? You can see that it cannot be simplified. So that's why I'm saying B cannot be equal to a 0. B cannot be equal to 0. Once B is equal to 0, that fraction is called undefined. It cannot be simplified. 2 over 0 like this, it's undefined, cannot be simplified. All right, so we're not gonna talk much, guys. We need to go straight to what we are into. So like I was saying, If we can write this in this form of A over B, we have a rational number, meaning to say rational numbers, what we refer to as the rational numbers, which can be formed or which can be written in the form of A over B, they consist of all integers. Why are we saying all integers are rational numbers? Okay, let's take a number such as 10. It is an integer. Can we write 10 as A over B? Every whole number, or every number actually, can be written as over 1. 10 can be written as 10 over 1. Remember the identity: when you divide by 1, the number remains as it is, meaning to say 2 over 1 remains as 2. Once you divide by 1, there is no effect. You can use your calculator to prove that. 100 divided by 1, it's 100. Any number, it remains as it is. So meaning to say a whole number, that is all integers, can be written back as rational numbers because we can write it as a fraction. 10 over 1, it's a fraction. 2 over 1, it's a fraction. We have written it in the form of A over B. A over B. Where A and B are what? Are referred to as integers. Positive or negative whole numbers. So we are saying all integers are referred to as rational numbers. On this part again, we also consider all proper fractions. Let's just say all proper fractions. All proper fractions. Definitely, they are supposed to be our rational numbers because this is the case that we have there. Let's say we've got 2 over 3, 7 over 8, 10 over 11, where we have got a bigger value in the denominator. All these fractions, they are referred to as rational numbers. They can be referred as rational numbers. Also, all improper fractions. All improper fractions. They are also rational numbers. Improper fractions, this is where the numerator is bigger than the denominator. 10 over 3, 11 over 7, 20 over, let's say, a 7, like this, where the numerator is bigger than the denominator. That's an improper fraction. It's also a rational number because we also have this form of A over B, and these are integers. The numerator is as long you can write it in the form of a fraction like this, it is referred to as a what? As a rational number, meaning to say, if we can talk of an improper fraction, remember an improper fraction such as 8 over 7, it is also taken from where? From a mixed fraction. 7 into 8, that's a 1. We're having a remainder of 1 over 7. This is an improper, right? Improper fraction, where we have got the bigger number in the numerator. This is a mixed fraction where we have got a whole number and we also have a fraction. There's a whole number and a fraction. So we talk of what? A mixed fraction. So if an improper fraction is a rational number, it also means a mixed fraction is also a rational number. So all mixed fractions, they are part of the rational numbers. We also have all terminating decimals. As long a decimal ends, all terminating decimals. All terminating decimals. A terminating decimal is the one that ends. When you write it, it ends like 0.2. It is ending, guys. It is a decimal which has ended. 0.5, 0.7. These decimals, they do end. When you're talking about non-terminating, guys, does not end. Does not. Those are decimals that when you simplify on your calculator, they do not end. Not a repetition. They are those decimals which do not end in a certain manner which are called recurring decimals. Those ones are also part of rational numbers. All recurring decimals. I'm going to talk about this. Guys, you need to know all this. All recurring decimals. All recurring. A recurring decimal is the one that ends. It is the one that it does not end in actual sense, but it is a repetition of values. Like let's say we've got 0,111111111 like that. That's a recurring. One is repeating throughout, or it can be 0,21. It can be like this: 21, 21, 21, 21, 21, and so on and so on. Is 21, 21, 21, and so on. 21 is repeating. There's 21, there's 21, there's 21 after the comma. So they can write it in short. If one is repeating like this, we can just write it in short as 0,1 with a dot on top like this. It means one is repeating and so on and so on. 0,21, if I put these two dots like this, it means 21 is repeating. 21, 21. So if you see decimals which are written like this, those decimals, they are part of rational numbers. Guys, these are different types of numbers, types of fractions, but all together they sum up to build rational numbers. They build rational numbers. So I hope we are together there, because they can ask you that, is this number going to be a rational number? You are given a certain decimal or you're given certain values, then they're asking you, is this one a rational number? So if they ask you, let's say 0,21, and they ask you, is it a rational number? Yes, it's a rational number because of what? It is a terminating decimal. It is a decimal which ends. It has ended, guys. Right? These are the only two digits after the comma. It has ended. It has ended. A decimal which does not end is something like we've got 0,1, 3, 7, 4, 5, whatever that you are given, and so on. It is, and there is no repetition of values. That one, it's a non-terminating, does not end. Non-terminating. It is not part of rational. It is not part of rational numbers. No, we do not have that. Those are decimals that you obtain from numbers such as square root of 2, square root of 3, square root of 5. When you simplify those square roots, which are referred to as the irrational numbers, this is the part that now we refer to as the irrational numbers. Let's take square root of 2. All right, this is the square root of 2. 1,4142. Look, guys, these numbers. The calculator, it just gave you the digits that it can hold. If you use a different device, let's say you've got a phone, you see that it can even have more decimals than this. Here we are just given, this is what our calculator can hold, but it does not end. This decimal does not end. It does not end. And these values, they are not repeating, like I was saying, to say 0,21212121. Yes, this one does not end, but it is a repetition. It is called a recurring decimal. There's a difference there. Both, they do not end. They continue like that. But the difference is that this one, the numbers, they do not repeat. They are just numbers on their own. Let's take square root of 5. Look at the square root of 5, all right? Sorry for that. The square root, you need the square root of a 5 like this. Okay, let's change this. Look, the numbers are just differently, randomly presented. It is not a repetition. It is different from something like this. If I write 1/7 like this, this decimal, guys, if you look properly like this one, you see here, it does not end. It is a repetition that shows that it does not end this one. But in its not ending part, like the way that it is not ending, there are values that are going to repeat. The 142,857, this one that is given in a bracket like this, it shows that that one, it is going to be repeating. It is going to be repeating. So it can be given in different manners as long it can be given or it can be written back to be a fraction. Then it becomes what? A rational number. I hope that we are together. So the opposite of these rational numbers are the ones that you refer to as the irrational numbers. All right. So the irrational numbers, they cannot be expressed in the form of A over B. We cannot express that way. Okay. That is the part of the irrational numbers. So the part of the irrational numbers, we cannot express this one in that format. And also the symbol, you need to know the symbol for the rational numbers. We refer with the symbol Q, and the irrational numbers, that's a Q with a bar like this. So these ones, they are numbers that show non-terminating decimals. Those decimals that do not end, like I was saying, we've got terminating. So these ones, we are going to take all non-terminating decimals. All right, all non-terminating decimals. They are going to be part of these. All right, all non-terminating decimals. We are also going to consider there. So the issue that they cannot be expressed as ratios. All right, so we have non-terminating decimals. We have got non-recurring decimals. If the decimal is not recurring, that is non-recurring decimals. Those ones, they are part of what? Irrational numbers. That is, cannot be expressed. It cannot be expressed in the form, all right? It cannot be expressed in the form A over B, where A and B are what? Where A and B are integers. It cannot be expressed in, cannot. If that number cannot be written as a fraction like this, it means that is a what? The irrational number. So combining these, the irrational numbers, the rational numbers together, that is, we are giving what we call the real numbers. This is what we have. This is what I wanted you to understand here. This is where we have the real numbers. Any number on the number line. That is, we are talking of what? All rational and irrational numbers put together. It builds up the real numbers. So as long numbers can be on a number line, we can have a 0 here, a 1, a 2, a 3, -1, -2, but also in between, we can have decimals there, 0,3, we can have 1,5, we can have whatever that we have in between these numbers. We can have the square root of 5, the square root of 7, and so on, combined to, as long a number can be, as long you can state that number, it becomes a real number. So the opposite now is non-real. The non-real, those are numbers which do not exist at all. That is the non-real. Like the square root of a negative. You can't simplify square root of -3. You can't simplify 3 over 0. Remember, we talked about this. Those ones now, they are not part of the real numbers. They are non-real. All right, so guys, that's it. I just want you to go through these basics, like I was explaining, go through the summary of the number system. Know your natural numbers. All right, talking of when you're talking of the counting numbers, but in this case, 0 is not included on natural numbers. So we're going to take from 1, 2, 3, and so on and so on and so on. 0 is not included. 0 is included on whole numbers. All right. So the natural numbers, they can represent this with the letter N for natural numbers. Then for the whole numbers, that is N with a 0 there. That is N naught. That is 0 is included in that case. So 0 is included. Here, 0 is not included on natural numbers. Then the integers, like I was talking about, that these are positive or negative whole numbers. So we talk of positive or negative whole numbers. Positive or negative whole numbers. So you can talk of -3, -2, any negative or any positive. 0 is included on integers. 0 is included. All right, then the rational numbers, those are the one that I was talking about, can be written in the form of A over B. So take note, this is the letter Z for integers. Then this Q corresponds to what? Rational numbers. So the letter Q for the rational numbers. So they can be written in the form of A over B. This is the part that I was explaining, that they can be written in this format of A over B. So that is what you need there, where A and B are integers and B cannot be equal to 0. Then also, this is the list of numbers that can be given as what? As rational numbers. I think I listed every number that you see there, the integers, the proper fraction, the improper and mixed numbers, the terminating, the recurring decimals. Then we also refer to the irrational numbers with a bar, Q with a bar like this. Talk of the non-terminating decimals, non-recurring decimals, the square roots of numbers that are not perfect squares, the cube root of numbers that are not perfect cubes, etc. So that is where we refer to the square root of 3, maybe the square root of 7, the cube root of a 5. These cannot be simplified. They become the irrational numbers. Like we do not know these values by head. We cannot even simplify by head. They can be simplified with a calculator. They can be simplified with a calc, but it's an endless decimal. And also pi. Pi is an irrational number. Please take note. Pi is an important symbol that you have in your mathematics, which represents irrational numbers. All right, I talked about the real numbers. So gonna move on to number 7. Calculations that do not produce real numbers. All right, there are calculations which do not produce real numbers. Which calculations are that? I talked about this division by 0. This one does not exist. The square root of negative numbers, I think I listed everything, guys, to show you that this does not exist. The square root of -3, the square root of -4, the square root of -9. These numbers, they do not exist. So at the end, they become non-real values, undefined. Division by 0, I talked about this, dividing a number by 0 like this. These numbers, they do not exist mathematically. So this is what you need, guys. This is what you need. So let us quickly use this information to attempt this example. Example 1, we're given to state whether the following numbers are rational, irrational, or neither. That is not one of these. All right, let's start with number 1, 0.25. All right, 0.25, is it rational or irrational? 0.25, it is already ended, guys. It is a terminating decimal. It has ended. It has ended like this, as you can see. So this one is a rational number. Remember, we said rational number, we talk of all terminating decimals. All right, terminating decimals, they are part of what? They are part of rational numbers. So this one is a rational number. It is part of what? The rational numbers. That is a rational number that we have there. Remember, the symbol for rational number is the symbol Q. All right. If you want to write the symbol, you can write the symbol Q. All right. So 0.25, we can also prove this because we said it can be written in the form of A over B. We know that 0.25 is 1 over 4. It is written in the form of A over B. You can use your calculator. All right, 0.25. All right, let's take our calculator, guys, and see. Another way that you can easily check 0.25. It's a decimal. You can see it is as a fraction 1 over 4. Can be written in this form of A over B. where the numerator and denominator are what? Are integers. So this is what they want. We move on to minus 4 on this B. Minus 4. Is minus 4 a rational number? Yes, that's a whole number. That's an integer. Positive or negative whole numbers. An integer. This one. So meaning to say, minus 4 can be written as minus 4 over 1 as a fraction A over B. So it becomes what? A rational number. So remember I said rational number is represented by the letter Q. All right, what about pi plus 8? Pi plus 8. Remember we said pi is not pi, this pi. It is not a rational number. So if we add 8 to that, is it going to be a rational number? No. It is just like, guys, we have got a decimal which cannot be simplified. We have a decimal, let's say 1,2,3, whatever, 254. This decimal cannot be simplified. Then you add an 8 or you add a certain number here, then it becomes 9, it does it change because you have added a 9 here, an 8? No, it does not change. So this one, it is an irrational number. It cannot, we cannot write it in the form of A over B. Okay, let's take our calculator and see. That is pi. All right. So we're going to have this shift and use this one, then plus 8 like this. All right. So if you check, change this SDD. Cannot be changed to a decimal. Look. Whatever that you have, it is not a repetition. This one, it's a non-recurring decimal, does not end. So that's an irrational number. All right. So we move on to another one, the square root of 11. All right. That's an irrational number. We say, remember, we said irrational numbers. That is where we talk of the non-terminating decimals. All right. These are they do not end. Square root of 11. This one does not exist. Square root of minus 11. Remember, we said the square root of a number cannot be negative. This one does not exist mathematically. This one, it is neither. Remember, we want to have rational, irrational. So this one, it is not a rational. It is not an irrational. It is undefined. We cannot simplify that one. All right, let's move on to F. We've got the square root of 9 there. Can we say square root of 9 is a rational number? All right, square root of 9, can it be simplified? That's the first thing. Square root of 9 is equal to 3. So 3 is a whole number, same as 1. 3 is an integer, 3 over 1. So that's a rational number because it can be written in the form of A over B. So the square root of 9, it is part of what? Rational numbers. Guys, 2 over 3, it's already a fraction. It's already in the form of A over B, a proper fraction. That's a rational number. H, 5 over 0. Remember, I said you cannot use the denominator with a 0. This one cannot be simplified mathematically. It is undefined mathematically, meaning to say it is not rational, it is not irrational. So that's one, we just put it on the neither. It cannot be simplified. That is undefined. All right. We move on to I, which is pi over pi like this. Remember, x over x is equal to 1. If two digits are the same, 2 over 2, they can cancel, give us a 1. So pi over pi gives us a 1. So is 1 a rational number? 1 can be written as 1 over 1, meaning to say we can write it in the form of A over B. So that's a rational number. All right. If we move on to another one, we are given 0,3232. Take note here. 32, it is a repetition there. 32, 32, and so on and so on. 32, 32, 32, and so on. So this one, it is called a recurring decimal, the one that repeats. It is just like this, 0,32. Then they put a dot and a dot here. It shows that 32 is repeating. It is a recurring decimal. And remember, we said all recurring decimals are what? Are rational numbers. So this one, it is a rational number. What about this one? This one, guys, it is given 0,6. 8204, whatever that we have there. So can we say this is a rational number? Can we say this is an irrational number from what we are given? What can we say from this? This is a non-terminating decimal, a non-recurring, does not end. It is, guys, this one shows that our calculator just took the values that it can. Otherwise, it is not ending. Otherwise, it is not ending. So that's an irrational number that we are having there. All right, so that is it, guys. We just need to work with as much presence as we can. So here, remember, we say this one is neither rational, no, irrational, meaning to say it is undefined. We cannot simplify that one. So that is how questions can be given as they can give you just few, then you pick, maybe it's number one is given A, B, C, choosing from the letters A, B, C that you're given. So for you to understand this, do revisions, work as much questions as you can, practice as much questions as you can. So it is not a lot, but if you do not revise these basics that we are talking about now, these basics, all your level, grade 9, grade 10 is going to be something else. Know these basics, know your rational numbers to the fullest. All right, so that's what we had, guys, from Maths Zone African Motives. Till we meet again.